So getting back to how these constants are used, well, they're basically used to determine whether to surround the code generated by these blocks with parentheses. And one thing I should mention here is that you can't actually just look at the block alone and say, yes, this block will have parentheses around it and this one won't. What you'll have to do is you'll have to not only look at the block itself, but the input that it is being placed in right there. Right? So you'll notice over here that the code generated from this text block over here, which is, remember, the A, B, C, D, E, F, G, H, I surrounded by single quotes, you'll notice that it does not have parentheses. Right? So how does it determine that? Well, it looks at the return value of this text block's generator, right? It looks at the second item here, right? So the code is going to tell it to actually, again, just be the A, B, C, D, E, F, G, H, I. Here, I'll just sort of mention as an aside, it gets the field value of text, which is the A, B, C, D, E, F, G, H, I. It runs this quote function on it, which you don't have to worry exactly what it's going to do. Just over here for now, you could imagine that it's just going to add single quotes around it. That's going to be the code. And this is going to, again, tell this second item or this first item, depending on whether you start indices at 0 or 1. But this last item in this list that's being returned is going to tell it, it's going to sort of indicate when to put parentheses, right? So this is basically saying that I am an atomic, or my code is, this block's code is an atomic operation, or rather, in this case, there are no operations. It can't be split by anything else, so it will never need parentheses. And the thing it's actually comparing it to is going to be this over here. So when we actually asked for the input named input, right? So when we're asking for the code from this, we're passing this constant, this number, to say this is something, if you have a precedence that's less than or equal to, or I should say if you have a lower precedence or same precedence as this, then you'll need to add parentheses. Now we said atomic operations will never need parentheses, but of course the computer doesn't know what atomic means. So what it's going to do is it's going to compare the numbers of atomic versus member. And remember we said that as you go down this list, you are getting operators that are the same or lower precedence. So you'll see order member, right, has the same or lower precedence as order atomic. But again, the way the computer knows this is it compares the floor of each of these numbers, right? So the floor is just going to be the greatest integer that's less than or equal to these numbers here. For numbers that are 0 or positive, you could just think of that as just removing what comes after the decimal place. So it's going to compare the floor of 1.2, which is 1, to 0, and it's going to say that, well, 0, which is last item of the return value of that text block, right, that 0, it's going to compare that 0 to the floor of the input here, this order member, which is just going to be 1, and it says, okay, 0 is less than 1, so I'm not going to need to add parentheses around me, right? Now, if we look at the other one over here, right, this is also a text block. So again, it's never going to be, you're never going to have parentheses added around it, no matter what input it's in. But here, instead of comparing order atomic to order member, it's going to compare order atomic to order none, right? And order none basically says, look, no matter how weak the precedence is, right, or no matter how low the precedence is, you will never need to add parentheses, right? So you see again, it has the highest number here of these, right? So it's going to compare the order none to the order atomic. It says, okay, 0 is less than 99, so I won't add parentheses there, right? But the floor of 0 is less than the floor of 99. Again, that's just 0 and 99 anyway. So I'm not going to have parentheses. But again, no matter what number we were using here, it would always be, other than order none itself, it would always have a number smaller than 99, right? The floor of any of these numbers is smaller than the floor of 99, right? So the question really becomes, how did we know to say that this input should be order member, whereas this one should be order none? Well, to know that, we would look at the code that's going to be where this code is going to be placed, right? So this the code that's generated from this block, right, is placed right before the period, right before the period split, as we can see here, right? So if it has a precedence that is lower than that period, then that period could actually wind up being applied to part of that part of the thing that we put here. So part of the code generated from the block that's here, and we wouldn't want that. So let me just give an example of this, right? So if instead of having just this single text block here, I put this text block in a create text with, right? So this is going to be text concatenation. And I'll just duplicate this block here. And I put something like, I don't know, Blockly is fun, right? And then I just put this in here, and I did to JavaScript again. Now you'll notice that this is put in parentheses before the period, right? And if it weren't put in parentheses, right, then what we would have is rather than this whole concatenated text, rather than split being called on this whole concatenated text, right, or just taking the whole text here and splitting it on commas, you would actually only apply it to this, right? So this create text with, this whole block here, the code that's generated from that would be split, right? No pun intended. Right? So again, how would it know to add parentheses here? Well, if you go to the export to XML, we can see that this block over here, right, is a text join block. Right? So we go back to our text generators, right? And we go down to text join, which is here, right? And we'll see a lot of stuff here, but the point that's actually relevant here with the one that is actually used, you could see is going to be this thing with the plus, and we could see that this returns a list, right, with the code and then order addition. So here it's comparing order addition to the order member over here, right? And when you look at that, you see, okay, order member, if you take the floor of that, that's 1, and order addition, if you take the floor of that, it's 6, right? And 6 is clearly not smaller than 1, so it will put parentheses around the code that's generated from these blocks here, right? So again, it goes back to how do we know what we put here, right? How do we know to use order addition or order member? Well, what we're looking for is we're really looking for when we do the return, right? So when we did a return here, we're looking for the operator that if you take anything stronger than that or equal to that or something that has stronger precedence or equal precedence to it, that code might get split up.